Parabolas. A parabola is the graph of a quadratic function, which is the set of all points x, y in a plane that are equidistant from a fixed point called the focus and a fixed line called the directrix. Now, if you remember back to the beginning of the year, we've already done parabolas. We've already graphed them, but now we're going to take a closer look at a couple things. The two new things that are really going to pop up here is, first of all, this thing called the focus. The focus, first of all, I'm going to point out, is on the interior of the parabola, and it lies on the axis of symmetry. So we already know what the vertex is. So the vertex is kind of right there at the bottom of our U-shaped graph, our parabola. And then the focus is a point that's going to sit kind of in here on the inside of our parabola. The other thing that's going to be new to us is called, it's over here, the directrix. The directrix is perpendicular to the axis of symmetry, which cuts the parabola in half, and it's this line that's going to lay down here. Now, if I take any point on my parabola, so let's say the point right here, and I find the distance from this point down to the directrix and over to the focus, that is going to be the same distance. If I kind of travel up my parabola and I find the distance down to the directrix and over to the focus, then those are going to be the same. And by doing that and connecting all of those points, that's how we find the shape of our parabola. Now, in the past, our parabolas were either going to open up or they were going to open down, which if you look over here, those are the two that we are familiar with. So the parabola is opening up or the parabola is opening down. There's actually two other versions that we're going to use here. And our parabola can also open to the left and open to the right. Now, let's take a closer look at what the equation is going to look like when this happens. In the past, the equation that we used was we used y equals a times x minus h squared plus k. Now, this equation was used when the vertex was somewhere other than the origin. And on these specific examples, we're gonna just put it at the origin, which means hk is 0, 0. So now we're really just looking at y equals a x squared because h and k are 0. In the past, the a value, if you remember, told you to go from your vertex over 1 and up or down how many, which essentially told you the width or how wide your parabola was going to be. If you take a look at your equation here, it's very, very, very similar, except do you notice instead of an a, they have 1 over 4p. Now, p is very important because p tells you the distance from your vertex to your focus and from your vertex to your directrix. So this distance is p, and it goes p up or p down. On these examples, you go p this way or p that way. So this is p and this is p. And then the same over here on the other ones. From your vertex, this is a distance of p, that's a distance of p. From your vertex, that's a distance of p, that's a distance of p. Now there's one other thing, well actually two now that I think about it, that we have to point out. If your parabola is pointing up, then the graph of this is going to be a positive. If your parabola is pointing down, then this is going to turn into a negative. If your parabola is pointing kind of to the right, or it's opening to the right, this is going to be a positive. If your parabola is opening to the left, then this takes on the negative. So we have to be very careful with our positive and negative. Then the last thing I want to point out that is not on these pictures is something that's called the lattice rectum. Okay, so we're going to add that over here, and we're going to say lattice rectum is 4p, and it goes for both versions. Now, what the lattice rectum is it's kind of taking on your a value, and you see it sitting right here. It's the 4p. It's the 4p. And just like your a value, it tells you how wide your parabola actually is. So from your focus on any one of these pictures, you go out to the left, you go out to the right. This distance is 4p, which is your latus rectum. There's 2p on the left, 2p on the right, and it shows you exactly how wide your parabola should be. Example 1, writing an equation of a parabola with a vertex at the origin. So, example 1, write the equation of the parabola with the given information. In letter A, F stands for focus. We have a focus at 0, -3, and then we have a directrix at y equals 3. I always draw a picture, and I'm going to recommend that you draw a picture. So 0, -3 is right here, and that's our focus. And then our directrix is at y equals 3. So up here at 3, your directrix is the horizontal line, y equals 3. Now, a couple things we can figure out from here. First of all, your vertex has to be right in between the focus and the directrix. So I know first of all that my vertex is right there. So my vertex is at 0, 0, right in between. The other thing I know from this is that your parabola always kind of goes away from the directrix so that the focus is on the inside. So I know my parabola is pointing down. Now, if the parabola is pointing up or down, that's kind of the versions that we've done in the past, which means now I'm dealing with a y equals. If my parabola is going to point left or right, then this equation would change and it would become x equals. So y equals 1 over 4p x squared. So the last thing I have to figure out is I have to figure out, okay, well, what's p? So if you count the distance from your vertex to your directrix, this is 3. If you count the distance from your vertex to your focus, that's 3. So we know p equals 3. Then we have y equals 1 over 4p x squared. And then we clean that up. Y equals 1 over 12 x squared. And we're almost done. There's one thing I forgot here, and it's the fact that my parabola is pointing down. Different teachers like to address this different ways. From your vertex to your focus, this is a negative distance, so you could say p is negative. I just like to look at it and say, well, in my original equation, it's pointing down, so that should be negative. So this should be negative, so that should be negative. And that's the equation. Letter B. You have a focus of 2, 0. You have a directrix at x equals -2. Again, draw a picture. If your focus is at 2, 0, you're over here. A directrix of x equals -2, that is now a vertical line at -2. If we think about where our vertex should be, it is right in the middle of the focus and the directrix. So we know it's going to sit right here again at 0, 0. The other thing I know is that the parabola goes away from the directrix towards the focus so that it's on the interior. So really roughly, I know my parabola looks like this. Now, if your parabola is opening left or right, this is no longer a y equals equation. It now becomes an x equals equation because it's opening left to right. Everything else is pretty much the same, 1 over 4p. And then now instead of x squared, we're going to have a y squared. Based on our last example, it is opening to the right. So because it's opening to the right or the positive direction, we know that this 1 over 4p is going to remain positive. So then we just have to find the value of p. If you look at the distance between your vertex to your directrix, your vertex to your focus, both times, p is 2. So then x equals 1 over 4 times 2 y squared. X equals 1 over 8 y squared. And that's your equation. Letter C. This time we have a vertex at 0, 0 and a directrix at x equals -3. So vertex is at 0, 0. directrix that is at x equals -3. Keep in mind x equals is a vertical line. So this time, this is not my focus. It's actually my vertex, which means my focus is somewhere over here on the right. For the sake of writing your equation, you don't actually need it, but you do need to know that this parabola is going to open in this direction away from the directrix towards the focus. If I'm trying to find my p-value, I really only need to know one of these. So this would be 3. 1, 2, 3. And because it's opening to the right, I know we have an x equals positive 1 over 4p y squared. If I fill in my p-value, x equals 1 over 4 times 3 y squared. X equals 1 over 12 y squared. Letter D. This time we're given a focus at 0, 3 halves. Keep in mind that 3 halves is kind of like 1 1/2. Well, not kind of, it is. So 1, 2, and my focus is going to be right here. Our vertex is at 0, 0. Based on the knowledge that that's the focus, that's the vertex, I know my parabola is opening this direction. Then I can look at the distance between my vertex and my focus, and I know that P is 3 halves, or 1 1/2. Because it's opening up, I know this one is a y equals. It's also opening up, so I know it's 1 over positive 4p, and then x squared. So we've got y equals 1 over 4. P is 3 halves, x squared. And then y equals 1 over, if we take 4 times 3 halves, I can simplify my 2 with my 4, which leaves me at 2. And then that's going to give me 6 times x squared. And that's the equation of our parabola.